Okay, 7.2, we start talking not so much about congruent triangles anymore, but about something different called similar polygons. And the objective today is to identify similar polygons and apply properties of similar polygons to solve problems. So some of you guys are probably wondering, what the heck is similar polygons? Well, we have just like this symbol means congruent, we have a symbol for similar, and that sign is just a little tilde. So the top part of that congruent sign, this is a similar sign. And this equal sign means equal. Okay, so the word similar means that the shapes, the polygons, aren't necessarily the same size, but they are the same shape. So we know similar means same shape, but not necessarily same size. And there's two important things about similar polygons. We know that their corresponding angles are congruent to each other. And since they're not necessarily the same size, that means that their sides aren't necessarily congruent, but they are proportional. So corresponding sides are proportional. And remember, proportional just means similar. So, for example, one's being reduced by a half or multiplied by 2. So that's what similar polygons are. And when I ask you for a similarity ratio, that's just basically the comparison, right? Ratio means comparison. The comparison of the lengths of corresponding sides. And that's going to be important when we need to verify if polygons are similar. So for example, let's say I have this equilateral triangle, ABC, and then I have this other equilateral triangle, DEF, and I know in my picture it looks like they're congruent, but they're not. Let's say that side ABC has lengths of 3, and in equilateral triangle DEF, they have side lengths of 6. Well, if I wanted the similarity ratio of triangle ABC to triangle DEF, well, since I talked about ABC first, I have to use the side of ABC first. So that would be 3. And then I'd have to use triangle DEF. So that would be 6. And so if I reduce that, I know my similarity ratio would be 1 to 2. Great. That means that ABC is half of triangle DEF in terms of their side lengths. Okay, so how can we describe similar polygons? That's the first thing we're going to do. First of all, we're going to identify the pairs of congruent angles and the corresponding sides. So we have to do two things when we're describing similar polygons. We have to talk about their angles, and remember the angles are going to be congruent to each other. And then we're going to talk about their sides. And remember the sides are not necessarily congruent. They're similar, so that means they're proportional. Okay, so if I look at this picture, I'm going to identify which angles are congruent to each other. So I know angle B is congruent to angle G. Sweet. I know angle C is congruent to angle H. And then since this is a triangle, even though they don't tell me anything about angle A or angle J, I know they have to be congruent because of the third angles theorem. Or if you don't remember what that theorem says, basically since there's 180 degrees in every single triangle, since this one's 90 and this one's 59, this one has to be, I think, 21 degrees, right, in order for them to add up to be 180. And so the same thing over here. If we added these up and subtracted from 180, this one would have to be 21 degrees. So I know that angle A is also congruent to angle J. Sweet, that's important. Remember, in similar polygons, the corresponding angles must be congruent. Now, I also know that the corresponding sides must be proportional. So if you're kind of confused about which side corresponds with which side, you can look at the angles. For example, I know B and G are congruent to each other, so that means the sides across from B and G must be proportional. So if I wanted to look at the side across, that would be side AC must be similar to the side across from angle G. So must be similar to HJ. Okay, and then, yeah, and then I can look across from, I can keep doing that. So the side across from angle C would be AB, must be similar to the side across from H, which is JG. And then if you really don't want to look across, if that confuses you, another way to do it is just to match up the smallest number on one triangle should be similar to the smallest side of another triangle. So for example, in this triangle, 3 is the smallest side. In this triangle, 6 is the smallest side. So that means BC must be similar to HG. So there's different ways you guys can use, different methods you guys can use to figure out which sides correspond to each other. Okay, so you're going to try to do that same thing for number 2. And then also try to do the reflection. Example number 2 is identifying similar polygons. So this time we need to determine whether those polygons are similar. In example number 1, I told you that they were similar. In example number 2, you need to tell me if they're similar or not. And if so, write the similarity ratio, which is what we talked about up here. So example 1 to 2. And write a similarity statement. So we've got a lot to do in number 3. I'm going to scroll down and I'm going to zoom in so we can see this a little bit better. Okay, so number 3. Let's see. First of all, in order to determine whether polygons are similar or not, we need to do that same process we did before. So are the angles congruent and are the sides similar? Those are the questions we need to ask ourselves. So let's look at this. I know triangle PQR is an isosceles triangle, and I know STW is also an isosceles triangle, which is cool. And that'll help us out with the angles, because that's the first thing I'm going to look at. Well, in an isosceles triangle, since these legs are congruent, that means these base angles also have to be congruent. And since there's 180 degrees in a triangle, what I'm going to do is I'm going to say, okay, 180 minus 36. That leaves me 144 degrees. And since these angles are absolutely congruent, they have to be, I have to take this and divide it by 2. So this is, I think, 72 degrees. Did I do this right? 100, let's see if I did my subtraction right. 180 minus 36. 0. Yeah, that's 144. Okay, so this one's 144 divided by 2 is 72. So this one's 72 degrees as well. All right. Well, 72 doesn't look like 62, right? And these should be corresponding. So since the angles are not congruent, the triangles are not similar. Let me try this over here and just double check that I did my math right. Similarly, if these legs are congruent, these base angles have to be congruent. So this one's going to be 62 degrees as well. And then if I add those up, 62 plus 62, that's 124. And then if I subtract that from 180, let's see what I get. I have to subtract. Okay, so that's 56 degrees. So again, since these angles are not congruent to each other, these corresponding angles are not congruent to each other, the triangles are not similar. So I can say that triangle PQR is not similar to triangle STW because their corresponding angles are not congruent. Okay, number 4, try to do number 4. We'll talk about number 4 in class a little bit more. Again, this is a similarity statement, much like a triangle congruency statement. The similarity ratio, had their angles been congruent, I would have wanted a similarity ratio, and that's just where you compare one side length to another side length. So for example, it would be 10 to 5, and then you would reduce that, and it would be 2 to 1. But we don't really need that since they were not similar. Okay, last thing we're going to do is example 3, we're finally going to solve. So again, in example number 3, I'm going to tell you now that these polygons are similar, so you do not have to figure that out. What you do need to find is the missing side length. So what you're going to do is you're going to set up your very own proportion. So you're going to compare the sides, and how I'm going to compare the sides, and it's okay if you want to do it in a different fashion. I'm going to take the sides from the first polygon and compare that to the second polygon. And I know that those sides should be proportional, right? So they should be proportional. So in this proportion, they're going to be equal. And I'm going to compare, there's lots of sides, right? So I'm going to compare the bottom side to the side, if that makes sense. So for example, in this first polygon, the bottom is 2x, and the side that they give me is 10. And I'm going to do that same thing for that second polygon. So the bottom is 9, and then the side is 15. And then to solve this, you guys were really good at this yesterday, we just need to cross multiply. So 2x times 15 is going to equal 9 times 10. So 30x is going to equal 90, divide by 30, x equals 3. And you're done. You're going to do the same thing for number 6. Number 6, they give you a little bit of information. Again, just take 2 sides. You do not have to compare all 4 sides. For example, I didn't even use this 12. I didn't need it. Okay, number 7, real-world application. You guys see models every day throughout your life and throughout your day, and you know, models obviously are proportions and scaled-down versions of the real thing. For example, in Vegas, the Luxor Hotel, which we've talked about a couple times, isn't necessarily, or the Eiffel Tower isn't exactly the same size as the real thing. So they use proportions to scale things down or up. And number 7 says find the length of the model race car to the nearest centimeter. To set it up, we're going to do a proportion just like we did over here. So my proportion, again, it's okay if you do it a little differently than mine. I'm going to say that the race car on one ratio, and then I'm going to compare the model in another ratio, and I'm going to compare the side to the trunk because that's the information they give me about. So in the race car, the side is 5 meters. And the trunk of the race car is 101.8 meters. And then I'm going to do the same thing for the model. So the side is x, and the trunk is 6.3 centimeters. And you're going to cross multiply and solve just like you did over here, and I want you to do that on your own. But when you solve, I want you to notice the units. On this proportion, on this ratio, excuse me, it's meters, and in this one, it's going to be centimeters. So meters to meters, centimeters to centimeters. So when whatever your answer is, it's going to be centimeters. And then also try to do reflection number 3. So today you did an awesome job with similar polygons. You guys do have a video to watch for con, or I'm sorry, not video to watch. You have practice with con, and that con practice is called, let's see, what's today, Friday? Oh, for con practice, it's going to be called Similar Triangles 1. Similar, yes, I did spell that right. Similar Triangles 1, that's an S. All right, so you're responsible for doing that this weekend. Also, fun fact of the video, did you know that a mouse can squeeze through a hole the size of a piece of popcorn? That is pretty impressive. All right, have a great weekend.